Welcome to the calculator section. Just a reminder, we left off at question number 28. So this next question will be the 29th question. So, with that being said, for which of the following is f prime positive and increasing? Well, f prime is going to be positive and increasing. That will mean that f prime being positive means that f is increasing. And so f prime being increasing will mean f double prime is positive, will mean that f is concave up. So we are looking for where that function is increasing and concave up, and that is at E. Both increasing and concave up. Next. Which of the following is guaranteed by the intermediate value theorem? Well, intermediate value theorem says if f of 2 is 10 and f of 4 is 20, and we are continuous, which we are, intermediate value theorem says that I have to cross every point in between 10 and 20 at some point between 2 and 4. No matter how I draw my curve, that f has to hit every single point in between. If I'm going from the first floor to the fourth floor, then I have to at some point hit the third floor and pass through the third floor. So if I start at 10 and end at 20, to get there at some point, I had to have gone through 13. Part D is what the mean value theorem says, if it's differentiable, by the way. This would be mean value theorem. Intermediate value theorem just says that we hit every value in between if we're continuous. The graph of e to the tangent x minus 2 crosses the x-axis at one point between 0 and 1. So first off, you need to pull out the calculator and figure out where that is. Where does it cross the x-axis? So find the 0 at that point. And then what is the slope of the graph at this point? So what is y prime at that point? And we should get D. That's some calculator work. If you need help with calculator work, then let me know. But yes, we want the derivative at that point where we hit a 0. This question, I actually put a harder version of this on a test at one point. Which of the following gives the average velocity? So average value of velocity. Well, I either want average rate of change of position or just average value of velocity. Average value of velocity is 1 over b minus a times the integral from a to b. Here's your graph of f prime. So we're got 3 different statements. We need to pick the ones that are true. So f has a relative minimum at x equals -3. So at -3, our f prime is here. Well, it looks to be at 0. And it looks to be changing from negative to positive. So since f prime is changing from negative to positive, that means we've got a minimum. So that one is true. Point of inflection at -2. Well, here's -2. At -2, for f to have a point of inflection would mean that f prime well, let's see. F having a point of inflection would have to mean that F double prime changes sign. And that would mean that F prime needs to change from increasing to decreasing, or from decreasing to increasing. In other words, in order for there to be a point of inflection, F prime needs to have a maximum or a minimum. And does not have a point of inflection, because that is not a max or min. That second derivative is going to equal 0 since it levels out, but it does not change. It was second derivative is going to be positive before and positive after, so no point of inflection. So graph of F being concave down means that F double prime needs to be negative, which means that F prime needs to be decreasing. And we look from 0 to 4, from 0 out to 4. That looks like it's going down. So 1 and 3 are the true statements there. Next. Water's being pumped into a tank at a rate. So this is my rate in. This is my rate in, where T is the number of minutes. If the tank contained 800 gallons when the pump was turned on, how much is in tank after 20 minutes? So that is my initial condition. So at T equals 0, my amount is at 800. So 800 is my starting amount. And then I want to know how much it's changed between 0 and 20. That means integral from 0 to 20 of R of T dt. And then it's a matter of putting it in the calculator. Same thing for 82. 82 is also a matter of putting it in the calculator. I want to know when F has a local maximum. Maximum means that this should change from positive to negative. F having a maximum means that F prime should change from positive to negative. And so we put it in the calculator, put that function in the calculator, look at where it changes from positive to negative, and it's going to change from positive to negative at C. Next page. Graph is showing velocity. What's the best estimate of the distance traveled from T equals 0 until the car comes to a complete stop? Well, the car comes to a complete stop at 8, since that's where the velocity is 0. And one way I could approximate this is to go ahead and use the way that I would approximate this is to use a Riemann sum, since I want to know my integral from 0 to 8 of v of t. So I would draw out, maybe do a left Riemann sum and determine what this estimate should be. But in general, we are looking for this area, and we're looking to estimate where that area is. And the closest estimate ends up being at 210. So I would use some kind of Riemann sum to give us a good idea of where that would be. You could also use a midpoint one from 0 to 2, and then from 2 to 4 and 4 to 6. That would be another good way to approximate it. 84. I want to know when f is concave down. Well, f is concave down. We just got finished talking about this. This is my first derivative, so this is when f prime is decreasing, which will mean the second derivative will be negative, which means that f will be concave down. So I want to know when f prime is decreasing, so I graph that. I see where it's going down, and it's going down here. Again, this is mostly a calculator question, and just testing that you know what concave up and concave down mean, and how to test for it in those derivatives. More max and min. Local maximum should mean that f prime goes from positive to negative. Going from positive to negative. And so that graph of f prime is going from positive to negative at 1. Next. Let me get everything fit into here. All right, this one's a tricky one. F prime is greater than 0 means we are always increasing. So let's go ahead and eliminate some choices right away. Anything that's not increasing is out. This is not increasing. This is not increasing. So anything that's not increasing is out. And then I know that the integral from 4 to 7 is 0. If the integral from 4 to 7 is 0, that means that I have to have a situation where I'm basically canceling out areas. So if this is 4 and this is 7, then I need to have a situation like this, where this area cancels out with this area to make the integral 0. And so the only one that starts below and ends above so that the areas can cancel is B. That one's a trickier one. All right, for 87, let's go ahead and ask the same question again in a different way. When is f concave down? Well, this time it's giving you the second derivative of f. So when f double prime is negative. So when is f double prime negative? Boom. Boom. There's where f double prime is negative. And that will tell me when the function is concave down. Next. Person whose height is 6 feet is walking away from a street light on a straight path at a rate of 4 feet per second. And we want to find the rate of the shadow. All right, let's label some stuff in this diagram. We actually did one like this before. And the key part that we're using here is we're using similar triangles. So first off, let's take care of our constants here. the things that aren't changing. My 6-foot person is going to stay 6 feet. My street light is going to stay 15 feet. All right, none of these warp to be taller or shorter. Now, I know that the distance, so we have x is my distance here along from the street light to the person. And then I also have s, the length of my shadow. And we are given the rate that they're walking away from the street light. So we are given dx dt to be 4. Since they're walking away from the street light, that's going to be a positive rate. And we are trying to find ds dt. So we can use similar triangles to solve this. 6 over 15 equals s over x plus s. Now, I could do this as a quotient rule, but that would make life much more complicated when I could just get rid of the fractions by cross-multiplying here. So I have 6 times x plus s equals 15s. So let's just go ahead and move those to the other side. 6x plus 6s equals 15s. And that gives me that 6x equals 15 minus 6 is 9s. So now I have something that is much easier to deal with those distances. So now I work with my related rates. And now I say that 6 derivative of x is dx dt equals 9 ds dt. And so I'm going to plug in 4 for my ds dt to solve, plug in 4 for dx dt to solve for ds dt. 6 ds dt. Or actually 9 ds dt. And so that's 24 equals 9 ds dt. So that's going to equal 8 over 3, which is b. So a lot more complicated one, but we actually did a related rates example like this one in class. So hopefully it looked at least a little familiar to you once we went through that one. But if you didn't get it, don't panic too much about it. That was a hard question. Next. Particle moves so that the acceleration is given by that function. Well, that means that velocity is going to be v of 0 equals 5. So that means v of t equals 5 is my starting point plus the integral from 0 to t of the acceleration function. So this will tell me how far away from 5 I am, and this tells me that 5 is my starting point. So v of 3, I started at 5, And then I see how far away from 5 I went from 0 to 3 in my acceleration function. Put that in the calculator, get out your answer. I'm skipping some of the calculator work here, but if you need to see any calculator stuff, just ask at some point. Ooh, this is a tough one. The easiest way to do this one is to just go ahead and take the antiderivative. So I know that f of 2x is 10. So let's I want the integral of f of x. Well, the integral of f of x would be capital F of x. And I would evaluate it from a to b. Now, when I do that for f of 2x, so I'm doing the integral of f of 2x, two different things happen when I do that. Watch carefully. Integral from 6 to 12 of f of 2x. So first of all, the antiderivative there will be capital F of 2x. But in order to work with that, that would mean that I need to, right now, the derivative of f of 2x is f of 2x, but then that's going to need the chain rule. So we need a 1/2 out in front of here to counteract that chain rule. So 1/2 can go out in front times plug in 6 times plug in 12. That means that capital F of 6 times plug in 12, I get f of 24 minus capital F of 6 times 2 is 12. This is 10. So that means that capital F of 24 minus capital F of 12 has to be 20. Which would be B. Another way you can do that is to show out the U substitution and change the bounds that way. So U equals 2x. That means that 1/2 du equals dx. And then go about switching your bounds that way. It would be the integral from 1/2 would come out in front, and then integral would be from 12 to 24 now, since I need to switch my bounds by plugging 6 and 12 in for x to get out what u would be. And then it would be f of u du. That answer is 10, so if I multiply by the 1/2, I get 20. That's the other way to think about this problem. Whatever way is most helpful to you. But it's that idea of counteracting the chain rule going on there. All right. Which of the following must be true? Polynomial function means we're continuous and differentiable. From -2 to 6, what must be true? Graph of f is concave up. Well, that can't be true because since we go 3 to 1 to 4 to 7, if graph of f were concave up, that would mean that f prime would have to be increasing the whole time, which it's not. Is f increasing? Maybe. It's not contradicted in the table, but it's also not guaranteed. What if at -1, what if I slipped in at -1, I dipped down to -2? Now it's not increasing all the time anymore. Again, we're looking for what has to be true. What is guaranteed? Not guaranteed. F has no critical points? Well, that's not true. Or that doesn't have to be true. What if, so again, maybe. But what if at -1 instead of at -2 we went down to 0? Bingo, there's a critical point. F has at least 2 relative extrema? Well, we don't know that either. We don't even know if it has a relative extrema, because it's staying positive the whole time as far as we know. So the only one that has to be true is that f has to have at least 2 points of inflection. That's because f prime has a min and a max. So at the minimum, which happens somewhere in between like -2 and 3, we have to have a point of inflection. And at the maximum, which happens somewhere in between 3 and 6, then f double prime is going to change sign, which means we have to have another point of inflection. So at least 2 different points of inflection. That's the only one that's guaranteed to be true. Some of these are maybe, but not guaranteed, depending on what the other table of values are. And finally, a nice little cross-section question to finish this off. So we have x squared and square root of x, which I'm going to go ahead and graph now. And the cross sections there are squares. And hopefully you should know, you can use a calculator, but hopefully you know without a calculator that these intersect at 1, 1. And now let's draw out our squares. Well, our squares here are perpendicular to the x-axis, so they're drawn this way. There's my square. There's one more square. And you'll notice area equals side squared. And what is our side? Well, our side here is just top curve minus bottom curve. Top curve is my square root function. Bottom curve is my x squared function. Again, hopefully you can figure that out just by hand. Here's the part where we might need the calculator. Area is going to be the integral from 0 to 1 of that side squared. So what was the side? Side was square root of x minus x squared. So that is the integral you're putting into the calculator. Put that integral in and you should get A. So that's it for the multiple choice. Let me know if you have any questions.